In this video, we're going to talk about energy. Now, energy is defined as the ability to do work. Some examples of work can be things like when you run, drive a car, fire. Those are all examples of energy. In this class, we're going to talk about two types of energy. We're going to talk about potential energy, which you can think of as stored energy. Sometimes you'll hear it referred to as the energy of position. And potential energy is exactly what it sounds like. It has the potential to provide energy, but it hasn't yet, if that makes sense. So, some examples are food. Food is a great example of potential energy. It has the potential to provide your body with food or with energy, but if you don't eat it, then it won't. Another example might be a rock at the top of the hill. So this would be a good example of energy of position because that rock has the potential to roll down the hill, but unless it starts rolling, then it's not really doing any of the energy yet. Now, kinetic energy is the energy of movement or the energy associated with movement. So, an example of kinetic energy might be running or a rock falling down the hill. The units of energy are joules, which is given the symbol capital J, and calories, which is given the symbol lowercase cal. There are all kinds of other units of energy, but these are the two that we're going to focus on in this class. Now, there are 4.184 joules in 1 calorie. In chemistry, when we're looking at energy, we use the word heat. And heat is a specific type of energy that is associated with molecules and how they are moving. Now, atoms and molecules are constantly in motion, and the faster they move, the more heat they're going to have. So, if you put heat into a system, the molecules will move faster, and this will result in more energy. Heat and temperature are not the same thing, and they cannot be used interchangeably. When we're looking at energy in a chemical reaction, we look at it in terms of that transfer of energy. And that transfer of energy is going to be in the form of heat. Now, sometimes a chemical reaction releases heat, and this energy is transferred from the reaction to the surroundings. So it would feel hot. And this is called an exothermic reaction. And it is where heat is released during the reaction. In an exothermic reaction, the energy of the products is lower than the energy of the reactants. Other times, we have reactions where heat is absorbed by the reaction. And what happens is you get energy that is transferred from the surroundings to the reaction. And this is called an endothermic reaction. And an endothermic reaction is one where heat is absorbed by the reaction or during the reaction. In an endothermic reaction, the energy of the reactants is lower than the energy of the products. Now, in chemistry, we have a specific word for the transfer of energy, and it is called the enthalpy. And it is given the symbol delta H. So you can think of it as kind of the change in heat within a chemical reaction. When delta H is positive, then that means we have an endothermic reaction. And we can think of energy or heat acts as a reactant, right? Energy is going into the reaction, it is being absorbed by the reaction. When delta H is negative, then it is an exothermic reaction. So we can think of energy and we can think of it as acting as a product. So that's how you can tell when the reaction is endothermic or exothermic is by looking at the sign of delta H.